There are 5 members in Group 2, which is Wilting with metric notes AF200155, Darrell Kev Vanadi with metric note CF200183, Aliyah Izzati binti Muhammad Zaini with metric note AF200045, Aizati Rushidia binti Muhammad Zaibiti with metric notes AF200025, also Iza Nur Hayati binti Sidat with metric notes AF200004.
So for the introduction today, I'm going to talk about is a two-story house architectural drawing, which is used for this project to analyze and to design the first floor beam, where each of our team member are assigned with one continuous beam and one simply supported beam, respectively. And a project is given with the intention of the proposing design of the continuous beam and simply supported beam based on the drawing in conjunction of the learning outcome of the subject for structural design.
My name is Wilting with metric notes AF200155, and I'm going to present about a continuous beam and simply supported beam. For simply supported beam that I had designed is 5/A to C. The beam size that I use in this design is 220 mm x 550 mm. Next is the load on beam 5/A to C. By referring to the table of shock coefficients for restraint to west leg, the panel of 5A to C is considered as the type of panel which is one shot edge discontinuous. Next is the main reinforcement. Since the MED is smaller than M flange and the condition is considered as neutral axis within the flange, before we determine the group of bar, the AS required is calculated. Since the AS required is larger than the AS minimum, by referring to the sectional of area of group of bar with the reference of AS required, the group of bar that I had designed is 2 number of bar with bar size 25 mm. For shear reinforcement, before the spacing bar is determined, the spacing should be calculated. In this design, I use H6 with AS equal to 57 mm square with the shear length that I calculated is 0.256. The end, by referring to the table of spacing bar, I designed the bar by use H6-150. For deflections, the factor of structural flange system K equal to 1.0. At the end, since the allowable effective depth is smaller than the actual, so the condition is considered as okay. As the summary, I found out that the bar that I use is 2H25 and the spacing is H650. For continuous beam that I designed is 1/B to G, and the specification is slightly same with simply supported with beam size 220 mm x 550 mm. The span length is about 10.797 meter and the width is 4.6 meter. Next is the action on beam 1B to G. By referring to the table of shear coefficients for two-way leg, the beam 1/B to G is considered as the conditions as two adjacent edge discontinuous. For analysis part, there are 3 cases. First is all span is maximum load, case 2 is maximum minimum, and case 3 is minimum maximum. Next is main reinforcement. Main reinforcement can be divided into 3 parts. First is span B to D. Since the K in span B to D is smaller than K balance, hence the compression reinforcement is not required. Also at the end, I found out that the AS required is larger than the AS minimum, hence the 2H25 group bar is used. Next is, since the K is larger than the K balance, so the compression reinforcement is required in support D and span D to G. Also the AS required in support D and span D to G is larger than the AS minimum, hence I found out that in support D, 5H25 is used for tensions and 3H16 is used for compressions. For D to G, I find out that 3H25 is used for tensions and 1H16 is used for compressions. There are also 3 parts in shear reinforcement. First is support B, second is support D, and the third is support G. For support B and G is using the same spar spacing, which is H650, and for support D is using H600. The deflection for continuous beam, the factor of structural system case is equal to 1.3. At the end, the condition is considered okay since the allowable span effective depth is smaller than the actual. As a summary, the group bar that I use in this design is 2H25, 5H25, and 3H25 for tensions, and 3H16 and 1H16 for compressions. However, for bar spacing is H600, H650.
So today I'm going to talk about the SS beam at the ground floor, which is 1 BF, and the CB beam, which is the first floor, D17. So today I'm going to talk about the simply supported beam for 1 B2F, which is my ground floor. And as you can see, the design life is 50 years. The set thickness I think is 250 millimeter. The unit weight of the concrete is 25 kilonewton meter cube, and the weight of the brickwork is 2.6 kilonewton meter cube. And I assume the bar 1 is 25 millimeter, bar 2 16 millimeter, and my length I take 6 millimeter. As you can see, my beam size is 220 millimeter times 550 millimeter. So the total design load, my W I get 48.21, and as you can see, my panel BF1 to 2, I get one-way slab, which is more than 2.0, and my shear coefficient I get 0.48. So as you can see, my MED I get 702.90 kilo Newton, and as you can see, my MF I got 38.84, which means actually there's a typo there. It's actually my MED is bigger than my MF, and then as you can see, my AS required is bigger than my AS min because my AS required is 3,356 millimeter square, and my AS min is 165.495 millimeter square. So as you can see, I use my AS request, which is 3,356 millimeter square, and for the beam, I'm using 3H40, which is 3,370 millimeter square. So as you can see, my shear reinforcement, my VD I get 260.35 kilonewton, which is my VD is smaller than 361 kilonewton and 524 kilonewton. As you can see, my VD is smaller than VD max for both, so therefore I use angle of 82 degree. And then for the shear links, as you can see, my S W over S I get 0.53, and I'm using the link H6 because in the previous one I assume my link is 6 millimeter, and the S W for the H6 link is 56 millimeter square, and you can see my S is 107.55, and you can see my max spacing for S max I get 376.25 millimeter, and I in this year reinforcement I use H600. So as you can see, the factor for the structural fan system K is equal to 1.0, and as you can see, my LD allowable is more than my LD actual, therefore the condition is okay. And on the left, you can see the summary drawing from beam 1 to F, and that's all from me for the simply supported beam. So next, we'll talk about the continuous beam from D to 1 to 7, which is the first floor. As you can see, the design life is the same 50 years. The slab thickness will be 250 millimeter. The unit weight of concrete is 25 kilonewton meter cube, and weight of the brickwork is 2.6 kilonewton meter cube. And I assume the bar one is 25 millimeter, the bar two is 16 millimeter, and my link is 6 millimeter. As you can see, the beam size is still the same, which is 220 millimeter times 550 millimeter. So the next one I'm going to talk about is the action. As you can see, the panel 1 to 7 CD, I get one way slab, which is more than 0, and my shear coefficient for the BV is 0.50. Well, my panel 1 to 7 DE, I get one way slab 2, which is more than 2.0, and my shear coefficient is still the same, 0.5. And as you can see, the total design load, my W, I get 42.53. So I'm going to talk about the analysis, which we have three cases study. The first case is the maximum, and the second case has maximum, minimum, maximum, minimum, and the next case is minimum, maximum, minimum, maximum. And this one is to determine the maximum for the SMD and BMD for each span. Next, I'm going to talk about the main reinforcement, which is the span 1 to 2. My design moment, I get 50.49 kilonewton. And as you can see, my next one, support 2, I get design moment is 41.16 kilonewton. And my span 2 to 3, and my design moment, I get 1.3 kilonewton. And as you can see, from my span 1 to 2, support 2, and span 2 to 3, my AS required is bigger than my AS mean. So for my support 3, I get the design moment is 30.73 kilonewton. And my span 3, I get span 3 to 4, I get design moment 25.70 kilonewton, and my support 4, I get 106.90 kilonewton. And as you can see, my support 3, my S request is bigger than my S mean, while my span 3 to 4 and my support 4 has the S request is smaller than my S mean. So for the span 4 to 5, my design moment is 66.84. As you can see, my AS request is bigger than my S mean in this span 4 to 5. So it's for my shear reinforcement, I got spot A, B, and C. So as you can see, my spot A, I got the design shear 65.47 kilonewton, and I'm using H675. Then my spot B, my design shear is 55.2 kilonewton. As you can see, I still use the same one, H675. And for my spot C, I use design shear 57.10 kilonewton and still using H675. And my spot D and spot E, my spot D using 116.87 kilonewton, which use H600, and my design shear for spot E is 79.40 kilonewton using H675. And the minimum shear link resistance, we use H675. So last but not least, I'm going to talk about the deflection of my continuous beam. So as you can see, my PO is bigger than my P, and then as you can see from here, the LD allowable is bigger than my LD actual, which means the condition is okay. And this deflection goes the same for all the span for my span for my whole span. So last but not least is the summary. As you can see, there is the detailing there for my continuous beam, and that's all from me for the continuous beam. Thank you.
Hi, my name is Noor Alexati. For simply supported beam, I choose beam 7 from A to C, while continuous beam, I choose beam 4 from D to F. This is the location for my beam, which is from beam 7 for A to C. For specification, for design life is 50 years, slab thickness is 250 mm. For total design load, W is equal to 1.35 GK plus 1.5 QK, 1707 kN per meter. So MED is less than MF. So neutral axis within the frame. Maximum cot theta is equal to 2.5 and VED is less than VRD. Maximum cot theta is equal to 1.0. Therefore, angle theta is less than 32 degrees. 8.65 is less than 1 over D, so it's allowable. Next calculation is continuous beam, which is beam 4 from D to F. Weight of brickwork is 2.6 kN per meter cube. W is equal to 38.36 kN per meter cube. This is the analysis. For main reinforcement, for span D to E, the design moment is 110 kN, and then the compression reinforcement is not required because K is less than KBAL. H6 150, and then for support F, the design shear is 39.08 kN, so use H6 300, larger than L over D actual, so it is okay. And then for the cracking, the bar spacing is 67.5 mm, so it's less than 150 mm, so it's okay.
Hi, my name is Azatulus Deputy Muhammad Zafidi. For simply supported beam, I choose beam 3 AC. This is the beam that I have chosen, and this is the design for this beam. For the B effective, my value is 858, which is less than 880. My value of B is 2310 millimeter. Then the value of effective fletch weight, which is 1078, which is less than the value of B. The characteristic of permanent load beam, the value of GK is 2.755 kilonewton per meter. Then the total of value of QK, which is 0.8494, 4 kilonewton per meter. Then the shear length for this beam is 0.08. Then the spacing for this beam is 950 millimeter. Maximum spacing for this beam is 376.5 mm. Limiting crack for this beam is 0.3 millimeter. Then the steel stress is 289 Newton per mm3. Then the maximum allowable bar spacing is 100 mm. Bar spacing for this beam is 796 mm, which is less than 100 mm. Then finally, this is the detailing for my beam. Next, for the continuous beam, I choose the beam D226. Then this is the design for my beam, same as the previous beam. When we calculate the moment distribution, we get the value of uniform distributed load, which is 90.87 kilonewton per meter. The span is from 2 to 6. The main reinforcement for span 2-3, which is 501 and 5.5 millimeter. Design for moment, which is 0.08. Then the value of area of tension reinforcement, which is 548.02. For case 1, all span maximum load is 90.84. Then the fixed end moment for M23 is 293.44 kilonewton per meter. For moment 3-5, the value is 593.21 kilonewton per meter. For case 2, maximum load for span 2 to 3, which is 90.84. Then for the span 3 to 5, which is the minimum load for this span, is 91.05 kilonewton per meter. Moment for 2-3 is 93.66 kilonewton per meter, and then moment for 3-5 is 321.56 kilonewton per meter. For the last case, the minimum span from 2 to 3 is 81.05. And then for span 3 to 5, the maximum load for this span is 90.84. For its fixed end moment, the M to 3 is 56.08 kilonewton per meter. Then for the value M35, the value is 291 kilonewton per meter. Finally, this is the detailing for my beam for continuous beam. Thank you.
My name is Isana Hayati, and I will jump to the next beam of simply and continuous beam of B1 till 2 and C2 till 6. For the first beam of simply supported, I choose beam B1 till 2, and this is the specification of the beam. From the value of the parameter of the beam, next we will find the value of the character value and the character variable. And from the value, we insert into the equation of total representation on beam, which is 1.35 GK plus 1.5 PK. And for this beam, we will obtain the value of the total design is 24.906 kilonewton per meter. After obtaining the value of Z, which is 0.72 D, we need to find the area of tension reinforcement. And we need to find the required tension reinforcement before we compare with the value of min and max reinforcement area that we will use in the future calculation. In shear reinforcement design, we will use the value of 42 degree to find the spacing capability of the beam. Next is deflection checking. So we need to identify the modification factor for the beam so that we can estimate the capability of the beam deflection. Next, for continuous beam of C2 till 6, the design of the beam is 83.59 kilonewton per meter. In order to find the value of the total design load, we need to find the characteristic of moment action and the variable action before we insert it into the formula. By calculating the fixed end moment, we can do a graphical presentation for the three cases of the beam. For the deflection checking, since the value of the actual span is smaller than the allowable span, so we can say that the beam are compatible and pass for the deflection checking. For crack checking for this beam, it is passed since the value of the bar spacing is smaller than the max allowable bar spacing.
So for the conclusion, as a result, we have successfully complete all the project goals. The major one is to show us how to design a building according with the Eurocode and examine the design of the beam and the slab. And then the main goal is to build the structure that can withstand all applied loads for the duration at its expected lifespan without failing. So through our application from this project, we can utilize our engineering knowledge and improve our technical proficiency in civil engineering, such as when we need to use AutoCAD or to create the beam detailing. Last but not least, in order to create a safe and long-lasting structure within the tolerance limitation in the future, it is crucial and required for us as a future civil engineer to have a correct and a good knowledge of structural design. That's all from us. Thank you.